The James Webb Space Telescope's latest image has unveiled surprising mysteries hidden on even a seemingly simple planet like Mercury. This revelation, located near the Sun, has prompted scientists to question their understanding of the planet's structure and secrets. Recent studies suggest that Mercury may harbor deep within its scorching atmosphere precious stones, along with an unexpectedly large and peculiar core. Modern technology has gradually begun unlocking the mysteries of this planet, starting with NASA's Mariner 10 mission in 1974 and the Messenger mission in 2004. These missions captured detailed images of a dense, crater-filled planet with a surprisingly strong magnetic field and a larger-than-expected core, forcing scientists to reconsider their knowledge of Mercury. The Messenger spacecraft, designed to orbit Mercury, collected a wealth of data, taking over 200,000 images that revealed areas never before seen. Some of the most intriguing findings were high levels of calcium and magnesium on Mercury's darker side, leaving scientists wondering how these elements came to be there. On Earth, magnetic fields are generated by the movement of liquid iron in the core, but Mercury's unique internal structure creates different magnetic properties. During the day, temperatures on Mercury can soar to 800 degrees Fahrenheit, hot enough to melt lead, while at night, they plummet to nearly -300 degrees Fahrenheit. Recent investigations have uncovered astounding features on Mercury's surface, such as volcanic activity in 2012 and water ice in some polar craters. These cold craters remain frozen year-round, raising questions about the possibility of even the simplest forms of life existing on the planet, despite its harsh environment. The European Space Agency's Bepi-Colombo mission, launched in 2008 in collaboration with the Japan Aerospace Exploration Agency, is on its way to Mercury and is expected to arrive in 2025. Mercury continues to surprise scientists with its powerful magnetic field, traces of water ice, and strange time patterns. A year on Mercury is shorter than a day due to its slow rotation and unique orbit around the Sun, which takes only 88 Earth days to complete. This slow rotation is thought to be the result of tidal locking, a gravitational influence from the Sun that has gradually slowed Mercury's spin over billions of years. Unlike our Moon, which is locked in synchronous rotation with Earth, Mercury has a 3:2 spin-orbit resonance, meaning it rotates 3 times for every 2 orbits around the Sun. This unique day-night cycle results in extreme conditions on the planet, with one side exposed to the Sun for long periods, becoming intensely hot, while the opposite side remains in darkness and extreme cold. Mercury's tenuous atmosphere, known as an exosphere, is constantly being lost to space and replenished by sources like solar wind, radioactive decay, and small meteor impacts. In 2012, researchers were stunned to discover much more water vapor in the exosphere than they had expected, likely the result of chemical reactions between hydrogen from the solar wind and oxygen in Mercury's rocky surface. Despite its small size and slow rotation, Mercury has a magnetic field, which was a surprising discovery from NASA's Messenger mission. This weaker magnetic field is thought to be generated by a unique process known as the dynamo effect within the planet's fluid metal core, influenced by Mercury's unusual orbit and rotation. This magnetic field shields Mercury from solar wind, which would otherwise strip away its thin atmosphere much more quickly. Studies of Mercury's fast orbit and slow spin have revealed unusual surface features, such as hot poles where the Sun appears to freeze overhead and icy regions near the poles that remain frozen due to their extreme cold. These cold regions have led scientists to consider whether other materials, such as organic compounds, could also be present on the planet. Investigating Mercury is a challenge due to its rapid orbit and long days, making it a difficult target for space missions. The Bepi-Colombo mission, which began its journey in 2018, is currently en route to the planet, using gravity assists from Venus and Mercury itself to adjust its trajectory. However, the spacecraft must endure intense heat during the day and conserve energy during long, cold nights. Ongoing studies suggest that Mercury may have once rotated much faster, but was gradually slowed by the Sun's gravity and collisions with large objects like asteroids. This provides scientists with new insights into the planet's past and helps us understand how planets in our solar system evolve over time. Mercury's enormous iron core, which makes up about 88.5% of its volume, is much larger than Earth's core, which accounts for only about 15% of its volume. Some scientists, such as Dr. Nancy Chabot from Johns Hopkins Applied Physics Laboratory and Dr. Eric Asfog from the University of Arizona, believe that Mercury may have once been a much larger planet. The planet's magnetic field, which is only about 1% as strong as Earth's, was another unexpected discovery made by NASA's MESSENGER mission. This finding challenges previous assumptions about the magnetic fields of smaller planets. Dr. Katherine Johnson, a planetary scientist at the University of British Columbia, and her team continue to study Mercury to better understand its unique characteristics. The planet's magnetic field is unusual, varying by about 1/5 of its radius, which could be due to the uneven thickness of its core, potentially altering how heat flows inside. In 2022, scientists discovered elements like sulfur, potassium, and sodium on Mercury's surface. These elements typically vanish quickly under high heat, making their presence on a planet so close to the Sun astonishing. Dr. Patrick Peplowski suggests that these elements may have originated from comets or asteroids that impacted Mercury after the planet's formation. Another remarkable discovery was the presence of water ice in craters near Mercury's poles, which remain cold enough to keep the ice from melting. These craters also contain organic compounds, carbon-based molecules that could resemble those that led to life on Earth. This suggests that Mercury might hold clues about the origins of life in our solar system. For a long time, scientists believed Mercury was geologically dead, but the MESSENGER mission found evidence of recent volcanic activity, such as areas on the surface that may have been volcanic vents. Mercury's southern pole is another enigma, with a wild and complex landscape featuring hills and valleys the size of Texas. Dr. Amarin, who studied data from the MESSENGER mission, found that Mercury has a fluid outer layer and a solid inner core, which could explain its strange magnetic field. These discoveries challenge our previous understanding of how planets form and evolve, revealing that there is still much to uncover about our solar system's nearest planet. Mercury's surface, characterized by the absence of plate tectonics and the presence of cracks and faults, provides valuable insights into the planet's geological past and development. Recent findings have shown that the surface is still changing, with small, localized valleys known as wrinkle ridges forming near larger features. Recent studies suggest these ongoing changes provide a glimpse into the dynamic magnetic field shaping this mysterious planet. This field may originate from a layer of liquid metal around a solid core, functioning like a dynamo. Breaks and fractures beneath the surface could allow heat and fluids to move through, and some scientists believe there may be pockets of water deep inside, kept from freezing by residual heat. This idea is not far-fetched, considering similar conditions found on other celestial bodies like Europa and Enceladus, which have subsurface oceans under their icy crusts. Investigating these hidden areas sparks curiosity and enhances our understanding of Mercury's ongoing processes. Each discovery helps answer questions about the planet's internal changes over time, the unusual materials potentially buried beneath its surface, and what these could reveal about the formation of our solar system and planets in general. These questions highlight the importance of continued exploration. Every new finding about Mercury's subsurface enriches our knowledge of the planet and contributes to our broader understanding of planetary formation and development in our solar system. With its extreme temperatures and proximity to the Sun, Mercury serves as a unique laboratory for testing our theories about how planets form and evolve. As we learn more questions arise, driving us to explore Mercury and other planets further. Mercury's surface, core, and processes are key to understanding its fascinating history and the development of our solar system. As technology advances, our ability to explore Mercury and other planets will continue to improve, leading to more discoveries and deeper insights into the universe. Mercury's geological history is closely tied to solar activity. As the planet is the closest to the Sun, it is constantly affected by intense solar winds and radiation, which shape its surface and atmosphere. Researchers believe Mercury's thin exosphere is constantly stripped away by these solar winds, resulting in a dynamic interaction between solar forces and Mercury's land features. One particularly intriguing aspect of Mercury is its ancient volcanic activity, which is now believed to have occurred later than previously thought. The surface shows signs of smooth plains, likely formed by old lava flows. These volcanic formations indicate that Mercury had a more dynamic geological past than was once assumed. Understanding the timeline of this activity is critical for grasping Mercury's development and comparing it with other rocky bodies in the solar system. Scientists are also studying the possibility of tectonic activity on Mercury, although not like what we see on Earth. The planet's crust shows signs of contraction, leading to features known as lobate scarps. These scarps are cliffs formed by the cooling and shrinking of Mercury's crust as it lost heat over billions of years. These features provide essential insights into Mercury's thermal history, suggesting that the planet was once significantly hotter than it is today. The discovery of water ice in Mercury's polar craters has sparked interest in the potential for habitability, however limited it may be. These polar regions are permanently shadowed, providing an environment where ice can remain stable. This raises fascinating questions about the history of water on Mercury and its implications for understanding the role of water in the solar system. Studies using data from NASA's MESSENGER mission have revealed that Mercury's surface is rich in various elements, including high concentrations of volatile compounds. This suggests that, despite its harsh environment, Mercury may have undergone processes that allowed these materials to settle and persist over time. Researchers are investigating whether these elements could serve as building blocks for life, even in the most extreme conditions. Another significant area of interest is impact cratering on Mercury. The planet bears the scars of numerous impacts, resulting in craters of various sizes. Some of these craters show signs of younger geological features, indicating a complex impact history. Studying these craters helps scientists reconstruct Mercury's past and provides clues about the early conditions of the planetary system. Mercury's magnetic field continues to present challenges and surprises. Its weaker magnetic field compared to Earth suggests a different dynamo process at work. Scientists are studying how Mercury's magnetic field interacts with solar winds and how this relationship protects the planet from solar radiation. This data could also enhance our understanding of the magnetic fields of other rocky planets. The ongoing Bepi-Colombo mission is set to significantly improve our understanding of Mercury. Equipped with advanced scientific instruments, the mission will conduct detailed measurements of the planet's surface, exosphere, and magnetic field. This mission aims to provide a comprehensive view of Mercury's composition and geophysical properties, which could revolutionize our understanding of planetary formation and evolution. As scientists continue to study Mercury, they are not only piecing together the history of this enigmatic planet but also expanding our knowledge of how planets evolve in different environments. The discoveries about Mercury add to the broader story of the diversity of planetary bodies in our solar system, demonstrating that even the smallest planets hold important secrets waiting to be uncovered. Mercury's unique characteristics extend beyond its surface and magnetic properties. Its atmosphere, or exosphere, is particularly fascinating. This tenuous layer is primarily composed of oxygen, sodium, hydrogen, helium, and potassium. Unlike Earth's thick and stable atmosphere, Mercury's exosphere is constantly in flux, shaped by solar activity and extreme temperatures. This instability raises questions about the processes that maintain the exosphere and its interaction with the solar wind. Another captivating feature of Mercury is its extreme temperature variations. The planet experiences the largest temperature swings in the solar system, with differences of over 1,000 degrees Fahrenheit between day and night. These drastic temperature changes are not only due to Mercury's proximity to the Sun but also its slow rotation. Understanding these temperature extremes is essential for future missions and the potential for robotic exploration. Mercury's geological features also provide valuable insights into its past. The presence of smooth plains, believed to be formed by ancient volcanic activity, suggests that the planet once had a more dynamic interior. Unlike Earth, which has plate tectonics driving geological change, Mercury's crust appears stable, although there is evidence of past tectonic activity. Scientists are particularly interested in how the planet's core influences its surface features, and whether these processes are still ongoing. The study of Mercury also highlights the importance of comparative planetology. By studying Mercury alongside Venus, Earth, and Mars, scientists can better understand how different conditions impact planetary development. Mercury's lack of a significant atmosphere and its intense solar exposure provide a sharp contrast to Venus's thick atmosphere and extreme greenhouse effect. These comparisons help clarify the conditions that lead to different planetary features and environments.